A very good morning to all of you. We are here today to discuss and observe how a traditional programming model works. Unless and until we are very clear about this concept of traditional programming model, it will be improper to start with Java programming. Because Java programming model is fundamentally different than the traditional programming model. Before we get into the model as such, let's reiterate a few facts. First amongst them is that the instruction set that is understood by different processors is different. For example, if you have an Intel microprocessor, then the instruction set understood by that microprocessor might be different than the one understood by, let's say, a Motorola microprocessor, or for that matter, an ARM microprocessor. When I say that the instruction set is different, I don't mean that the addition and the assignment and the multiplication, that would be any different across the processor. That would possibly remain same. But then there are some instructions which might be understood by one processor, might not be understood by another processor. So basically, instruction set understood by one microprocessor is likely to be different than the one understood by other microprocessors. Secondly, when it comes to the operating system level, then the way input-output is done on Windows is again different than the way it is done on Linux, is different than the way it is done on, let's say, Mac operating system. Not only the input-output, even the memory management is going to be different across microprocessors. So one difference is at the microprocessor level, another set of differences, that is I/O and memory management, those differences exist at the operating system level. That is why you have different compilers which are targeted towards a combination of microprocessor and the OS combination. That is why when you visit any site to download a software, it will give you choices. Do you want to download it for Windows, or do you want to download it for Linux, or do you want to download it for Mac OS? Why? Because the compilers are targeted for a OS and the microprocessor combination. This OS and microprocessor combination is often also known as a platform. That's why people say that this compiler works on this particular platform, it doesn't work on other platform. Just to give you an example, Visual Studio would work on Windows and Intel combination. It may not work with Linux and Intel combination. It has been targeted, it has been created by keeping in mind the Windows plus Intel combination. It has not been created keeping in mind the combination of Linux and Intel microprocessor. That is why PowerPoint also works on what? Works on Windows. For Mac there is a different PowerPoint. For Android there is a different PowerPoint. Right? So compilers and applications are targeted for a particular platform. Typical compilers, for example, could be Visual Studio, as I said, would be for Intel and Windows combination. Whereas GCC has been implemented for a variety of combinations. That is why you find GCC compiler available for Intex Linux combination. It is also available for Apple and Macintosh combination. Fine. So for different platforms, people target their compilers. The compiler which has been targeted for one platform obviously is not going to work for another platform. Having understood these facts, it's time to understand the traditional programming model. By traditional programming model, what I mean is model that is used or followed by languages like C and C++. Java and Python do not follow this traditional programming model. Their model is different. What is that model? That will come to later on. As of now, let's try to understand in detail the traditional programming model. Suppose we decide to write a C program. Now this C program will be ultimately compiled into machine language instructions for maybe Intel x86 microprocessor. The same C program can be converted into machine language instructions targeted for AMD x86 microprocessor. Or the same C program can be compiled for creating instructions in machine language as understood by the Motorola microprocessor. The instruction set of each of these microprocessors is different. The one understood by Intel may or may not be understood by Motorola, may or may not be understood by AMD microprocessor. So C program is compiled, the same C program, realize that, it will be compiled and targeted towards what? A specific instruction set for a specific microprocessor. And then this machine language code will be executed on, let's say, PC with Windows installed on it. Or the machine language instructions created for AMD x86 may be executed on laptop having Linux operating system on it. Or the program might get executed on Apple with iOS installed on it. What you got to understand is that the exe that is created for Windows will not work on Linux or Mac. Why will it not work? Because the compiler has been targeted to create instructions as understood by Intel x86 and Windows combination. That's why I said it's the platform for which you target the compiler. Program will have to be recompiled if we decide to target it for another platform. What you have to appreciate here is that the program remains same. C program doesn't have to be rewritten again and again and again just because the targeted platform has changed. Means our job of creating a program remains agnostic to which particular platform is that program going to get compiled for. Program remains same. That is why traditional programming model people say is write once, compile anywhere model. What do we mean by this? It means that you are required to write the program only once. But once it has been compiled for a particular platform, that same compiled code will not work on another platform. The machine language instructions created for Intel and Windows combination, those machine language instructions will not work for AMD and Linux combination. Program will have to be recompiled. So program remains same, but compilation will have to be redone the moment the target platform changes. That is why the dictum of traditional programming model is what? You write the program only once, but compile it again and again for different platforms. Once you understood this traditional programming model, it will be interesting to know how Java programming model is different than the traditional programming model. And that is something that we propose to do in the next lecture. Till that time, goodbye, good luck, and thank you. Hi friends, my name is Yashwant Kanetkar and I am here today to discuss with you a programming model which is very typical of Java environment. When you contrast it with traditional programming model, the one that is followed by languages like C and C++, you will find that there is a very fundamental difference between the traditional programming model and the Java programming model. So without much ado, let's try to understand this Java programming model. In this model, suppose we begin with a Java program stored in a .java file. Now when you compile this Java program, it gets converted not directly into machine language instructions, but instead it gets converted into some intermediate language instructions. And that intermediate language instructions are often known as bytecode instructions. So if you have a file pr1.java, on compilation it will create a pr1.class file, or a pr1.jar file. .class file or .jar file would get created. And then when this bytecode instructions have been created, they on the fly would be executed on the platform. During that execution, the conversion from bytecode instructions into machine language instructions will be done. So bytecode instructions once created can be executed after having converted them into machine language instructions for Windows x86 combination. Means Windows plus Intel combination, Windows plus Intel platform, or in short often also known as merely a Wintel platform. The same bytecode instructions can get executed on a Mac plus Motorola combination after having converted the bytecode instructions into corresponding machine language instructions as understood by the Mac plus Motorola combination. Same bytecode instructions can also get converted into machine language instructions as understood by the platform of Android plus ARM, where Android is the operating system, ARM is the microprocessor. Advantage of this is what? Advantage is that once conversion is done by the Java compiler and the intermediate language instructions have been created, there onwards the same instructions can be used to get them executed on different platforms. The conversion from .java file into a .class file would be done by the Java compiler, whereas conversion of bytecode instructions on the fly during execution into appropriate machine language instructions will be done by what is known as a Java interpreter, or sometimes also known as a just-in-time compiler. In place of a Java interpreter, JIT compiler might also be used. So compiler will convert from .java into .class and interpreter will convert from .class into machine language instructions. The advantage that accrues from creating this intermediate language code in the form of bytecode instructions is that you are required to compile the program only once, whereas you can run the compiled code into different platforms, different microprocessor and OS combination without being required to recompile the program. That, believe me, is a great advantage. Contrast it with traditional programming model where the moment platform change, you are required to recompile the program. That you don't have to do anymore. The same bytecode instructions can run on absolutely any platform. All that will have to be done is there is something known as a Java virtual machine that will have to be implemented for a particular platform. So long as a JVM or Java virtual machine is present for that platform, the same bytecode instructions will be taken by JVM and appropriately be converted into the machine language instructions as understood by that particular platform. That is why it is often known as a compile once but run anywhere model. Whereas traditional programming model, you are required to write the program once but compile it often. Here you are required to write only once, compile only once, run as many times as you wish on different models. That, believe me, is a big advantage as contrasted with the traditional programming model. So compilation will have to be done only once, writing of the program will also have to be done only one single time. The way Java programming model is fundamentally different than the C and the C++ programming model, same is true about the Python programming model. Or for that matter, C# programming model. Means all the modern languages have understood the importance and the advantage behind creating the intermediate language code. In case of C#, it's known as IL code or intermediate language code. In Java parlance, the same is known as the bytecode instructions. These are readable, human readable instructions. They are not machine language instructions. They get converted into machine language by the Java interpreter. So I hope I have clarified enough as to what is the difference between the traditional programming model and the Java programming model. Once you understand these differences, you are on a surer footing when you start actually writing Java programs, which is what we propose to do in lectures to follow. Till that time, goodbye, good luck, and thank you. Good morning, friends. I am Yashwant Kanetkar, and today I propose to discuss with you how input can be received for a Java program through what are known as command line arguments. Reading input from keyboard, we already know it can be done using the scanner class. But oftentimes you are also required to write programs wherein arguments for the program would be expected through command line. So we must know how to receive input as command line arguments. Now the way to provide these command line arguments would be different for different compilers. For example, if you are trying to run a program straightway on the web by using something like onlinegdb.com, then you will be required to give the command line arguments through this input tab. So first go to the debug tab, within that select input and then give the command line maybe as cat, dog and parrot. So we expect these three to be passed to our program, and we know that any Java program's execution starts with the entry point as main. So these cat, dog and parrot will be passed to our program and would be received by main, and then we can go ahead and process them. Instead of online GDB, if you are making use of maybe an IDE like NetBeans, then you are required to first right click on the project name that you get in the left tab, and from the menu that pops up, select properties. Once you select properties, you will see such a dialog. From here, select run option and then give the arguments as cat, dog and parrot. So that's the way to provide command line arguments if you are using NetBeans as IDE. Instead of NetBeans, maybe you are using some other IDE, then for that some other IDE you would be required to figure out how do you provide the input in the form of command line arguments. So that is something that is going to change from one IDE to another. Processing of command line arguments, however, remains same because that is something which is done within the Java program. So let's see how that can be tackled. Maybe I have a package name called command line args and a public class command line args containing main. And within main, now we will start using this string args array. Into this args array, whatever you provide at command line would get collected. Now if I am to access what has been provided as input for the program through this args array, I have to understand that this array is really an array of string objects. And since it's an array, I can access the elements of that array using the index. So I can very well say that if args contains cat, dog and parrot, then cat will be accessible to me by saying arg0. You can print it out on the screen by saying system.out.println arg0. Likewise, to access dog, you will say args1, and to access parrot, you will say args2. So arg0, args1 and args2 will give me access to cat, dog and parrot as the arguments that have been passed at command line and collected in main in that args array, which is basically an array of string objects. What you should also very carefully observe is that this is an array of string objects, means even if a number is provided at command line, it will be still received as a string. And if received as a string, you will not be able to do any arithmetic on it. What if I wish to do that arithmetic? Well, let's try to understand how that will be tackled. If 400, 210 and 430 are passed, they are also received as strings, as I just now said. And reason why they need to be converted into numbers is the way numbers are stored and the way strings are stored is fundamentally different. For example, if you take a number 210, then when I treat 210 as an integer, what will be stored in memory is its binary equivalent. We know how to obtain binary equivalent. Go on dividing by 2, write remainders, and finally rewrite them in reverse order. If you do so, you will get the binary equivalent of 210. That will be fundamentally different than 210 written within double inverted commas. If within double quotes, then it's treated as a string. And if it is a string, then each character within that string is going to be stored as its Unicode equivalent. So Unicode of 2, Unicode of 1, Unicode of 0, that is what is going to get stored, which will be very different than binary equivalent of 210. That is why if I want to do any arithmetic on these numbers, I need to convert them from their stringized form into their integer or float form before I can carry out those operations. Why don't we write a program which demonstrates how this can be done? Maybe what is provided as command line arguments is principal, number of years, and rate of interest. So basically 3 numbers. And we want to perform arithmetic on them to obtain simple interest. If that is the one that I wish to tackle, let's see how it can be done. Start with a package by the name simple interest using command line arguments. Then some public class main, inside which we have the public static void main. Within this, we will write the code to convert the stringized numbers into their numeric equivalent. Do realize that the name of this public class can indeed be main. That main you will appreciate is different than this main. You have a capital M here, there is a small case m here. Fine, that is perfectly okay. And assuming that these are the values that were provided as command line arguments, they are available in the form of string because of this double inverted comma. They were not supplied with double inverted comma, they were supplied as 3 numbers, but when received into this args array, they are received as strings. Now to convert them into their numeric equivalent, we need to make use of a ready-made class available in the Java library called float. That float class has got a static method called value of. Method means function. Within this class float, there is a static method called value of. I am calling it and passing to it arg0 means 1000.50. This is what is being passed to arg0. Fine. Once it has been passed, what it returns is a float object. This value of function returns a float object. And then using that object, I am calling a function called float value. The resultant floating point number would be stored in the variable p. Fine. Value of returns a float object. Within that float object, there is a method, there is a function called float value, and that is the one that I am calling. What I want you to observe here is that float is a class. So this is class.method, that's the syntax. Whenever it's class.method, it's always the static method that is being called. Whereas value of will return a float object. That float object dot value of a float value, when I call it's object dot method. When I say object dot method, it's the instance method. When I say class dot method, it means it's a static method. When we do object oriented programming, it will be amply clear to you as to what really is the difference between a static method and an instance method. Right now, just get used to the syntax. Class.method means it's a static method. Object.method means it's a instance method. On similar lines, I will make use of the integer class present in Java library. Call its method called value of. It will return me an integer object this time. Within that integer object, there is a instance method called int value. It will return me the integer value. I will collect it in n. Likewise, I can convert the rate of interest into some variable r and then get the usual simple interest done. Do define the variables. Finally, you can print the value of simple interest. So that is how you can make use of this float and integer classes to convert a stringized float into a floating point value or a stringized integer into an integer value. This appears to be a little difficult. That is why there is a simpler method available. That simpler method is just a float.parseFloat arg0. Within that float class, there is another static method called parseFloat, to which you provide a string, it returns you the float value from that string. We can collect that in P. So the way we can say float.parseFloat, naturally we will also be able to say integer.parseInt. Now question comes, do I also convert the character by saying character.parseChar? Well, that doesn't work, because for character, if I am to extract the character out of a string, I simply have to make use of a function called char@. Char@0 means get me the character at the 0th position. From a string, I can always extract the character using this char@ function. So string to character you do using char@. String to integer you do using integer.parseInt. String to float you do using float.parseFloat. So this technique you must remember, because oftentimes you would be required to receive input in the form of command line arguments rather than receiving those values as input from keyboard. So input source, if it changes, you can see fundamentally there is a change in the program. So much about how do we go about receiving input in the form of command line arguments. Goodbye and good luck. Hello folks, I am Yashwant Kanetkar, and today we propose to understand the intricacies of switch or the case control instruction. These intricacies are important as you go about making use of switch statement within your Java program. Switch ultimately is used to do what? To implement the case control instruction. Now within a switch, there are possibilities that the case may fail or the case may succeed. If a case fails, then I don't have to do anything. Control automatically jumps to the next case. That is the behavior of the case control instruction. As against that, if a case is satisfied, every single statement below that case up to closing brace of switch, they get executed. Any cases or default that it may come across, they would simply be ignored. If I do not want that to happen, then below the set of instructions for that particular case, always employ a break statement. On meeting break, control will come outside the switch. It will terminate the case control instructions execution. Now there is always a possibility that every single case that you have written within a switch fails. If that so happens, the control will jump to the default case provided it has been written within the case control instruction. Since default case is optional, it may not even be present. If it is not present, then control will go completely outside the switch if none of the cases are satisfied. So that possibility always exists. So behavior will be different if default is present as compared to when it is absent. If present and all cases fail, control will jump to the default case. Otherwise, it will go outside the switch if there is no default case. Not having a default case is not a crime. Why? Because default case, as mentioned here, is optional. Lastly and quite importantly, the order in which you write the cases simply does not have any bearing on execution. You may write case 1, case 2, case 3 within a switch, or you may say case 3, case 1, case 2, or case 2, case 3, case 1, or absolutely any other order that you may deem fit. because ultimately it's going to evaluate it case by case. Whichever case you have written first, that will be evaluated. If that fails, it will jump to the next case. If that fails, it will jump to the next case, so on and so forth. So you have complete liberty in changing the order of the cases inside a switch. Let's now look at some of the subtle issues associated with this case control instruction. Very, very important that it will work only for a char, a byte, a short, int or a long. In fact, byte, short, int and long are nothing but variations of the integer. So apart from integer, it will also work for a char. What are the differences between byte, short, int and long? Byte is 1 byte long, short is 2 bytes long, int is 4 bytes long and long is 8 bytes long. But basically all of them can hold what? Only integer values. Means for integers and char alone the switch would work. Do not try to make use of switch for float or a double. Means tomorrow don't say switch A and then case 1.5, case 2.5, case 3.5, case 4.5. That's not going to fly. You cannot check against float values, you cannot check against double values. Then what if I am genuinely interested in checking against float values? Well, who prevents you from using if? You can always say if A is equal to 1.5, if A is equal to 2.5. With if else there is no such restriction. It's only with switch such a restriction exists, that you can never check floats or doubles using a switch. Thirdly, even for a moment, don't believe that switch is a replacement for if. No. If is much more versatile. If can check whether A contains 1.5, 2.5, 3.5. It can also check whether A contains 10, 20, 30. It can also be used to check ranges. I can say if CH is less than equal to 60 or CH is greater than equal to 75. So I can write multiple conditions, combine them using OR, AND, etc. All of that is not something that you make use of in case of a switch. Switch is basically used to do what? To check whether value of a variable is one value, another value, yet another value, some other value. Specific values when you are required to check against, go for a switch. That's a better idea as compared to using if and else. Now, if there is a logic which can be implemented using if, it can also be implemented using switch. Question comes, which one should you prefer? Well, switch is likely to work faster than if. Why? Because switch is always implemented using what is known as a jump table. When you compile a program which uses a switch, a jump table is created in memory. That jump table contains what? It contains information that if value of a variable is this value, straightway jump to this particular address where the instruction for that particular value of switch or that particular value of case is kept in memory. For another value of variable that you are checking in switch, there is another jump instruction to which address should the control jump if that value is encountered in the switch variable. Since it is jump table based, it is very easy to do what? Jump to that particular instruction during execution. As against that, if you make use of if and else, the conditions of if and else are evaluated at runtime. So time will be wasted in doing this. Especially if the big instructions are there, big conditions combined using and or operators. If that is what you have used, all these conditions would be evaluated at execution time. In that sense, you should always go for a switch because that's likely to run faster than corresponding if and else. Choice of course is yours. You can implement the logic using switch. You can also do so using if else, or you can make use of nested if else's. Any of these three options are available at your disposal. Traditionally, people have been using switch whenever they are to check a variable's value against 4, 5, 6 specific values. That's when you go for a switch. So much about the case control instruction subtleties. Goodbye and good luck. Good morning, friends. My name is Yashwant Kanetkar, and today we plan to understand one very important concept in Java programming, namely the this reference. And what better way other than creating a Java program which exemplifies the usage of this reference. So let's try to do that. We will begin with a class called EX present inside a package called sample. Within this class EX, we have a private int I and a private float a. Then we have a public class sample, in which we naturally propose to make use of class EX. So inside this class sample, we will have main. When I say main and dot, it means public static void main string args. So that string args is to be assumed. And then I would create a new EX object by saying EX E1 equal to new EX. The way I have created one object, I can create one more object by saying EX E2 equal to new EX. So two objects we have created. And then we are going to call the set data function and pass to it 5 and 5.5f. I am making the call using the E1 object. In set data, whatever has been passed is being received in x and y. And all that we would do is, we would assign these x and y to I and a. So we are basically filling the values inside the object by calling this set data method. Now question here is that if I make a call to set data by saying E2, that time 10 and 10.5 would be passed and they would get collected into x and y and they would be assigned to I and a. So what happens here remains same whether the call happens through the E1 object or whether it happens through the E2 object. That brings us to a larger question as to whether these I and a, are they belonging to the first object or the second object? Common answer that people give is that, well, when using E1 when you land into set data, these are I and a belonging to the object pointed to by E1. Whereas when you make a call to set data using E2, that time these I and a are the ones that belong to the object to which E2 is pointing. So based on using which reference are we trying to reach set data, appropriately I and a of the first or the second object are considered. You ask them, how does this happen? Well, then they say it happens automatically. Automatic, in my opinion, is a very dangerous word. Believe me, in programming nothing happens automatically. There is always a logic at work. When you don't understand, you say it's happening automatically. In reality, what is happening is very interesting. When you are making a call to set data, it seems that we are passing two parameters to set data, an integer and a float. But in reality, what gets passed to set data is not only 5 and 5.5 in the first call or 10 and 10.5 in the next call. What additionally also gets passed is E1 and E2. And what do E1 and E2 contain? Well, E1 and E2 contain nothing but the addresses of these objects. Objects we know are always created on the heap and objects are always nameless. E1 and E2 are variables that are going to get created on the stack. And they would point where? To wherever the objects are present in the heap. So objects are always nameless, that is fundamental. Don't say E1 is an object or E2 is an object. E1 and E2 are what? References to the object. Objects themselves can never have name. So you are now convinced that to set data, what is being passed is E1 and E2, means references of the two objects are also being passed in the two calls. If I am passing three parameters from here, naturally in set data I got to collect them into three. There has to be a match between number of arguments that you pass and number of arguments that you collect. So this call to set data or this definition of set data is also modified by the compiler into something which looks like this. Ex final this int x float y. So 5 and 5.5 or 10 or 10.5 get collected in XY, that's no problem. But E1 or E2 that I pass gets collected into a reference known as a this reference. It is a EX this, means it's a reference of the type EX. And final is indicating that value present in this cannot change during execution of the set data method. So if this is pointing to the first object, throughout the execution of the set data method, it will continue to point to the first object. In the second call, if this contains address of the second object, then throughout the execution of set data during the second call, this will always point to the second object. Third change that the compiler makes is when I say IA, it internally converts it into this dot I equal to X and this dot A is equal to Y. I don't have to do this. I don't have to pass E1, E2. I don't have to collect into this. I will write code the way I have written it here, the way I have written it here, and the way I have written it here. This will get changed into this form, this will get changed into this form, and this one will get changed into this form, courtesy the compiler. I don't do this, compiler does this for me. And that is the reason why I am able to say that I and A are the ones that belong to object pointed to by E1 or the object pointed to by E2. When the first call is made, this will contain 400. At 400, which I and A are present? These I and A. In the second call, this will contain 500 because what are you passing? You are passing E2. E2 contains what? Address of the second object. So this would contain what? 500. That is why when I say I and A here, these are whose I and A in the second call? I and A of the second object. That is the mechanism that is at work. Many Java programmers don't know this. That should not happen in your case. You must know thoroughly well how is it able to distinguish between first and the second objects within the set data method. What works with set data works with absolutely any other method within the class. Tomorrow in place of set data, you have get data or print data. Even there, this pointer or this reference will be at work. A few things that you must remember about this pointer or this reference are as follows. Its usage is optional. We need not use it, but it is indeed at work for every single method. It is a constant pointer or a constant reference. It cannot be modified during execution of set data. That is why there is a word final there indicating that it's final. It cannot change during the execution of that particular call. Lastly, it dies the moment control goes back from set data. It is born when the next call to set data happens. So it is alive only for that particular call, dies when you go back from that particular method. That is how this reference works. Important concept, not known to many Java programmers, now known to you. So you are definitely on the right path. Goodbye and good luck. Hello friends, I am Yashwant Kanetkar, and today we propose to discuss a very interesting topic, namely intricacies of arrays that you make use of in Java programming. When it comes to declaration of an array, we know that array, since it is always treated as an object, it's bound to get created only on the heap. That's a rule that James Gosling made, that every object would always be created on the heap. Hence, the fact that array is always treated as an object, it means it is also going to get created in heap. Moreover, this array object would be a nameless object. Naturally, to refer to it, we would be required to make use of its reference. That reference would always be created on the stack. Suppose we have an array object containing percentage marks obtained by different students, then this array object would be created on the heap and its address would be stored on the stack in maybe some variable called PER. So PER would really be pointing to this array object present in the heap. Now if we are to declare this array object, then we have multiple ways to do so. Let me show you that flexibility. We can declare the array object by saying int PER bracket equal to new int 10. Notice that the array is always created by using new operator. So new array of integers, in fact new array of 10 integers would get created and its address would be stored in PER. PER bracket indicates that PER is pointer to an array or a reference to an array object. Alternatively, I can also do the declaration by first merely saying int PER bracket and then in a fresh line saying PER equal to new int 10. Not only that, I could also achieve the same result by saying int bracket PER and then PER equal to new int 10. What you can notice is the bracket that we are using, it can be given either after PER or before PER. Here we gave it after PER. In the next declaration we made use of the bracket before PER. It's an array of integers to which PER is pointing. That bracket is basically indicative of the fact that PER is pointer to an array or a reference to an array object. Now when it comes to initializing an array, realize that there are two possibilities. Either elements of the array may be known beforehand. Beforehand means at the time of declaration of the array, or we may not know beforehand. In either case, let's see how the array initialization can be done. If the elements are known beforehand, then I may just say int a bracket equal to, and then within braces mention the elements that we propose to store in the array. So here the elements are 7, 6, 11, minus 2 and 26. They have been put within a pair of braces. In such a case, I am not required to use any new or any such thing. In fact, in this case, I cannot even mention the size of the array here. Why? Because the compiler will count that totally there are 5 elements and then it will assume A to be a pointer to an array of 5 integer objects. Second possibility is that the elements are not known beforehand, means at the time of declaration we are unaware of what the values of the elements will be. In such a case, I may just say int b bracket equal to new int bracket 10, indicating that b is pointer to an array of 10 integers. In this case, mentioning the size becomes mandatory on our part. We cannot drop this 10. Why not? Because the moment I say new int bracket, it will allocate the object in heap. How big an object in heap needs to be created, that will be known only if you mention the size. So quite logical that in such a case we would be required to mention the size of the array. If I print out B0 in such a case, I would get value as 0. Means by default array elements would be initialized to a value 0. That is what I am trying to draw your attention to. I may receive B0, B1, B2 from the keyboard. That is possible. Using the scanner object, we know we can always receive value into an integer variable. Same can be employed to receive the value into an array element where the element is an integer. Or I may say B5 equal to 3 plus 7 mod 2, where array elements can be calculated. B5 is being calculated. You are doing the expression 3 plus 7 mod 2, whatever is the result of that expression, that would get assigned to B5. Not only that, I can also involve one of the array elements or multiple array elements to compute yet another array element. So arithmetic on array elements is also perfectly feasible. So this seems to be the recipe for even normal variables. Normal variables can be received from keyboard. They can be even calculated, or they can also be involved in any arithmetic. So question comes as to how is the array different then? Well, let's try to figure that out. One difference is that array is a collection of similar elements. A normal variable is only one single value. Whereas multiple values, if we are to gather together, then we need to take recourse to an array. Moreover, all these elements are similar. That similarity consideration must always be met whenever you are constructing an array. If I decide to create an array out of dissimilar elements, maybe 2, 1.4, a and 6. 2 and 6 we know are integers, 1.4 is a double and a is a character. However, we attempt to say int a bracket equal to 2, 1.4, a and 6. That would certainly result into an error because this similarity consideration is being violated here. These elements are not similar to one another. Two are integers, one is double, another is char. These are dissimilar elements. Secondly, array elements are always stored in adjacent or contiguous memory locations. Means if I create an array of integers holding such values, then they would always be stored in adjacent locations. As you can notice in the figure, A0 is present at 402. So A1 is bound to be present at 406. A1 cannot be anywhere else. This 45, the very first element, is really speaking occupying 4 bytes. So even though it begins at 402, it is occupying 402, 403, 404 and 405. That is why the next element is starting at 406. This 33 will occupy 406, 7, 8 and 9. That is why next element starts at 410. So on and so forth. So it is guaranteed that all array elements would be stored in adjacent memory locations. Thirdly, it is also possible for us to create array of floats, array of doubles, array of chars, so on and so forth. So array of any numeric values is perfectly acceptable. Only requirement is that similarity and adjacency consideration must be met. So long as that is feasible, an array is always on. Then it is not a programmer's responsibility to check the bounds of an array. By this what I mean is that if you construct a 5 integer array like this and then try to run a loop 40 times and within that try to print out AI. Well, 0 to 40 I cannot do because there are only 5 elements. We know that 30 is at A0 whereas 35 is at A bracket 4. So the moment I goes beyond 4, you are exceeding the bounds of an array. That's certainly going to result into a runtime exception. At runtime, an error will be thrown indicating that you are exceeding the bounds of an array. That is something which is not permissible. Instead of creating array of numbers, we can also create an array of characters. For example, I can create a char str1 holding such characters HELLO. And then I can run a loop saying 0 to str1.length. That length is really property of an array which indicates how many elements exist in the array. And then I can have it printed out by saying str1 bracket I. Instead of using this char array, you are also allowed to make use of a data type known as string. I can say string str2 equal to hello. This string is special only for characters. I cannot say that there are 5 integers, so get me some other way of creating an array holding 5 integers. No, that is not possible. This is only speciality of a character array. In place of a character array, I have a ready-made data type string which I can initialize by saying string str2 equal to hello. So this frequent use of single quotes gets avoided the way we did it here. That's not required in this case. We can just put all the characters within a pair of double inverted commas. I can print out the entire string by saying system.out.println str2. I need not run a loop the way I did when I created the char array. So string is really very helpful because there are so many situations where we are required to deal with a collection of characters. Since this need is frequent, that is why this string object has been facilitated in Java. Lastly, dimensions of an array can be a variable. I can say int n equal to 4 and then say int a bracket equal to new int n. So n being a variable can take any value. Here I have initialized the value of n to 4, so a 4 integer array would get created. However, I am at liberty to receive the value of n even from the keyboard. That you can see makes my array pretty dynamic. One day I execute the program, I give the value of n as 4, so a 4 integer array gets created. Next day I execute the program, I give value of n as 10, so a 10 integer array is bound to get created. Means you are not required to commit to the size of the array, you have the flexibility in changing the size during different executions. That really is a great advantage with arrays in Java. Goodbye, good luck, and thank you. Hi friends, I am Yashwant Kanetkar, and today we plan to understand how function calls can be made in the inheritance chain. Best way to understand this would be through a program. So let me straightway begin with a program. Suppose we have a class A containing maybe a function f1. So public void f1 containing, for want of a better message, I would say system.out.println a.f1, indicating that we are into a method f1 belonging to a class A. I would also have one more method f2 within which we print out a.f2. Then put the closing brace of class A. So two methods f1 and f2 within class A. And then what I do is I inherit a new class B from the existing class A. And within this, what I would do is I would define a method f2 in which we print out b.f2 and a method f3 in which we print out b.f3. We will also have one more method f4 which prints out b.f4. And then we will try to invoke these methods from main. To do that, let's create a public class sample containing main, public static void main string args, and inside this main, first thing that I would do is I would create a object of the class B by saying bz equal to new b. And using this z, now I would try to call the methods. First one would be a call to f1 by saying z.f1. Similarly, I would make a call to z.f2, then z.f3 and z.f4. Fine. What is important for us to find out is which method gets called when we make these calls. So let's identify that. I would try to write down the output that we get while executing the program. When I say z.f1, z is an object of class B. So this function f1 is bound to get searched in class B. It is not found anywhere in class B because B contains f2, f3 and f4. Hence, control now goes to the class A and there the search gets successful. That is what is the purpose of the inheritance. Firstly, the function would be searched in the derived class B, and since it is not found there, the search will be extended to the base class A, and here f1 is indeed found. That is why a.f1 is bound to get printed out. So in the output, we will get a.f1 printed out. Let's look at the second call now. When I do this z.f2, again f2 will be searched firstly in the class B. But this time the search is successful because f2 is indeed present in class B. Hence it will get executed. b.f2 is what would get printed out. Then I make the third call, that is z dot f3. When I do that, again function f3 would be searched in the class B. It is indeed found here, hence it will get executed from here, resulting into the output b dot f3. And when I say z dot f4, again f4 will be searched in class B. It is found here, so it is executed from here. But in the output, we not only want b dot f4, we also want a dot f2 to get printed out. For that to happen, this message will be printed the moment f4 gets executed. But here we need to do something to ensure that a dot f2 also gets printed out. Now where is a dot f2? Well, it's present here. Means from here I need to make a call to this particular function. If that has to happen, then I need to say super dot f2. The moment I do super dot f2, it would go to the base class. If I just say f2, in that case it would land the control here. I don't want it to reach f2 of b, I want it to reach f2 of base class, and I can ensure that by saying super dot f2. So basically we came across 4 cases if you notice carefully. First is, we now know that through the inheritance chain we would be able to use the existing functionality as it is. That is what happened in case of the function f1. It was there in the base class, we used it from the base class. So we basically made use of the existing functionality. Second purpose that the inheritance serves is, it lets you override the existing functionality. If you look at f2 was there in the base class, we didn't want that functionality, so we could override, we could shadow it out by defining a new f2 in the derived class. So existing functionality can also be overridden by using inheritance. Thirdly, if I want, I can provide a brand new functionality. Case in point here is the function f3. It was not there in the base class, but we implemented it only in the derived class. That was brand new functionality. And if we so desire, we can also have a combination of existing and new. f4 was that case. We called f4, but f4 internally called f2 of the base class. So that combination of old and the new. So these 4 very important purposes would be served by the inheritance chain. That is why inheritance is so popularly used in Java programs. Because in any program of reasonable complexity, you would be required to make use of inheritance. And while doing so, these 4 options are available at your disposal. You can decide which one of these are to be used depending upon their relevance for your particular problem. That is all. Goodbye, good luck, and thank you. Hi folks, I am Yashwant Kanetkar, and today we plan to understand a very interesting mechanism used in Java inheritance chain, namely the dynamic dispatch mechanism. Let's now try to understand this with the help of a program. Suppose we have a problem like this to solve, wherein within a window we propose to draw a variety of shapes. Maybe some circles, some rectangles, so on and so forth. Now here if you observe carefully, not only are we interested in drawing the rectangles and circles, additionally we want that the order of drawing of those shapes should be preserved. What do I mean by this? From the figure you can very well see that firstly this red circle must have been drawn, then a blue rectangle, then the pink circle, and then the green rectangle. That must have been the order, because that is how they have been superimposed. Now when I minimize the window by clicking on this minimize window button, window will disappear. It will go to the taskbar. After some time, if I again click on the taskbar, the window should regrow to its original size. Once the size is restored, this order should still be maintained. First red, then blue, then pink, and then green. So that order I should be able to maintain within my program. Then only I would be able to restore it. So if I am to ensure this, then I can create a shape class which is generic, and then from this shape class I may inherit a new class called circle, and from the same shape class I can also inherit another class called rectangle. This inheritance relationship, once I have constructed within my program, I need to store every new circle or the rectangle that I draw. For them, I would naturally create an object in memory. Somewhere I need to gather all these objects, and that somewhere is nothing but an array of shape references. So within that array of shape references, I would store the circle objects addresses, similarly rectangle object addresses. And then through a loop I can make calls to the draw function, and appropriately the circle or the rectangle classes draw function should get called. Let's see this code in action. I will first begin by declaring the class shape, within which we will have a simple draw method which maybe draws something or prints something on the screen. Right now we are just trying to provide a dummy draw function without anything within this pair of braces. These are empty right now. But in reality what I would do is I would actually have the code here to carry out the drawing of a shape. But realize that when I say draw a shape, I don't know which type of shape are you going to draw. That is why we should purposefully keep the base class, that is shape class's draw function, as empty. And then within circle class, which I extend from the shape class, I would have a draw method written once again. Means I am overriding the base class draw method. That is why I am saying we can leave this empty. And within this we will print out a message, system.out.println circle. In reality, I will have a logic here to carry out the drawing of a circle. Then put the closing brace. Then another inheritance chain that we want to construct is the rectangle class, which we extend from the shape class once again. Inside this also we will have a draw method which prints out a message, system.out.println rectangle. So from shape I inherited circle, from shape I also inherited rectangle. Then let's try to use these classes. So within main, what I would do is create circle objects. Realize that C1, C2, C3 are right now only merely references. We will have to say C1 equal to new circle, C2 equal to new circle, and C3 equal to new circle to create the objects and store their addresses in C1, C2, C3. Same thing I will do for rectangles. Create rectangle objects, store their references in R1, R2, R3. And then all these references together I will gather into a shape array in any order that you want, C1, R2, C2, so on and so forth. And once all these references have been gathered into an array affords me to do the iteration on it. So I can now run a loop saying I equal to 0 to 5, because totally there are 6 shapes that we have drawn, C1, C2, C3, R1, R2, R3. So 0 to 5, 6 times. Each time through this loop I would say si dot draw. When I do this si dot draw, the appropriate classes draw gets called. What do I mean by appropriate classes draw? Well, when I is 0, that time this will be S0 dot draw. What does S0 contain? S0 contains C1, means it contains the address of a circle object. Hence this draw will bring us where? To the draw of the circle class. When I becomes 1, this becomes S1 dot draw. What does S1 contain? S1 contains rectangle objects address. So S1 dot draw will bring me where? To the draw of the rectangle class. That is why I am saying that appropriately it will take us to either the draw of the circle class or draw of the rectangle class. And this is happening at runtime. That is why it's known as a dynamic dispatch mechanism. Dispatch mechanism means function call. Which function would get called? Well, that would be decided dynamically at runtime based on whatever SI fetches you. If SI gives you circle object's address, draw of the circle class would get called. If SI gives you rectangle object's address, it will then call the draw of the rectangle class. So suitable classes draw would get called. That is what is dynamic dispatch mechanism. Few tips about it are in order. First is that whenever you store the address of the derived class object into a reference to the base class, that process is known as upcasting, and the reference is known as an upcasted reference. So array that we created, it was really an array of upcasted references. In shape reference, we were trying to store addresses of circle objects and addresses of rectangle objects, making them upcasted references. And since there were many of them, we can call it as an array of upcasted references. Then there is a concept known as binding, which decides which function to call. Either binding or dispatch mechanism, that's one and the same thing. In Java, this binding is always done dynamically, that is at runtime, whereas in C++ you can also do it statically, that is at compile time. That is why C++ also offers you early binding apart from late binding. Now question comes as to why Java doesn't let you do early binding. For the simple reason that in Java all objects are always created on the heap, whereas in C++ you can also create them on the stack. So using the object you can make a call in C++, that's when early binding happens. But using a pointer to an object when you make a call in C++, that's the time when late binding happens. Since in Java objects are always nameless, they are always created on the heap, and they are always used through their references. Hence calls to methods will happen through references, and since these are upcasted references, you will land into the suitable classes draw function. Since this happens at runtime, Java offers you only late binding or dynamic dispatch. So early binding and late binding is also known as static binding or dynamic binding, or compile time binding and runtime binding. So this terminology might be different in different languages, but basically the concept is same. Java lets you do only late binding or only runtime binding, or lets you do dynamic dispatch. Early binding cannot be done in Java because in Java you can never create objects on the stack. Goodbye, good luck, and thank you. Hello friends, I am Yashwant Kanetkar, and today we propose to begin with a very important concept in Java programming, namely exception handling. Now realize when exception handling becomes necessary is the first question that we need to answer. Well, for that we need to figure out where things may go wrong when we are trying to create a Java program. Well, there are several possibilities. First among them is during compilation. Means if the grammar of your program is wrong, if it is not in line with the rules that have been laid down by James Gosling for the Java language, in that case the compiler would report the error. And what action is expected on your part? Well, you are supposed to rectify those errors. So grammar wise, if something is wrong, compiler will point it out to you, and your duty is to rectify those errors and then recompile the program. So those are fairly simple errors to deal with. Second possibility is that we make use of libraries within our Java program. So if for any reason we are unable to link those libraries with our program, in that case an error would be flashed. And that again will be easy to sort out. All that you are required to do is you are required to use the proper import statements at the top of your program. So these are also fairly straightforward to deal with. Third variety is what is cumbersome. During execution of the program, means once things have gone out of your hand, that's when the error occurs. When those errors occur, in that case, it would be reported by Java runtime, and we have to have the foresight and put that foresight into our program, thinking that when this execution happens for this program, such and such error is likely to occur and I need to account for it right away. So dynamically the error would occur and dynamically I would be required to deal with it. That's what I mean when I say tackle it on the fly. Now there are several ways in which these exceptions may occur. Just to give you a couple of examples, memory overflow is likely to occur in the form of stack overflow or heap overflow. We know that objects are always created on the heap, normal variables always on the stack. So if stack becomes full, a stack overflow would occur. Similarly, if we create so many objects that the heap gets overflown, then also an exception may occur or a runtime error may occur. Or we attempt to exceed the bounds of an array. We have created, let's say, 5 integer array and we try to go beyond those 5 integers. That will happen only when you execute the program or at runtime. So that's also a runtime exception related to memory. Then arithmetic related exceptions may also occur. For example, you may say C equal to A divided by B, and during execution B becomes 0. Denominator, if it is 0, division by 0 we know is not defined. Or we carry out an operation C equal to A into B, and during the course of that multiplication we exceed the range of the integers. In that case, a overflow would occur. Similarly, underflow is also likely to occur because all integers are within a range. Byte, for example, has a value minus 128 to plus 127. So if byte arithmetic is involved and you try to go beyond 127, an overflow would occur, and if you try to go below minus 128, then an underflow would occur. So that's something that is likely to happen only during execution. That's why it gets classified under runtime error or exception. Or to give you a couple of more examples, you try to use a reference which has not been assigned any address. So you say circle C1 and then say C1 dot draw. You should have said C1 equal to new circle to assign a reference to a variable C1. Without doing that, if you use it to make a call to a method, then it will also be reported as an error. Or you try to open a file and the file is simply not there on the disk. That's also going to result into a runtime exception. Yet another example could be that you are trying to connect to a network server or a print server or a database server, and somehow the connection doesn't go through. There is some network error. At the time of compilation of the program, this cannot happen, because at the time of compilation it is checking the grammar, it is not checking whether connection is going to materialize or not. That can be checked only when you execute the program. So if connection error is there, obviously it is going to be a runtime error. Point I am trying to make is that there are several things that may go wrong at runtime. And when these things go wrong, there are ways and means to deal with it. One category of exceptions is those which can be anticipated. If you can anticipate, you can initiate a recovery, but then there are some which cannot be anticipated, in which case recovery would simply be impossible. File not found or insufficient memory or division by 0, all of these are exceptions that you can anticipate that, well, during execution this may go wrong, let me make a provision for it right away. However, some exceptions cannot be anticipated. It might be due to internal condition or external condition. For example, passing null instead of a file name is something that you cannot really anticipate, that this is what the user will end up doing. Or if there is a hard disk failure while executing the program, that also you cannot anticipate. Ultimately, it's a device, it may go wrong, it may fail during execution. So those errors which cannot be anticipated, those qualify as unchecked exceptions, whereas those which can be anticipated, they qualify as checked exceptions. So when I say checked exception, the meaning of that word check is compiler checks whether these exceptions have been handled or not. Whereas first category here is known as runtime exceptions, second is known as errors. And together they are known as unchecked exceptions. Compiler will not check whether you have dealt with these or not, whereas checked exceptions, it will always check whether you have done something about these exceptional conditions or not. In case of unchecked exceptions, it is up to us whether we want to deal with them or we don't want to deal with them in our program. We are more worried about the checked exceptions right now. Now, when an exceptional condition occurs, in Java programming, it will happen only when a method is being executed. Because at any given point in time during the course of execution of the program, some or the other method is being executed. So exceptions, if they occur, they will occur only when method execution is in progress. How do you deal with them? Well, in Java, everything you deal in an object-oriented fashion. So naturally, exceptions are also handled in an object-oriented fashion. What do we mean by this object-oriented exception handling? Well, in this, any information about the exceptional condition that has occurred, that information will be packed into an object. This is an important thing because more information can be packed into an object as compared to merely returning an error number. You can put several items of information within the exception object. These exceptional conditional objects that you create, the fact that they are objects means they are going to be instantiated out of some or the other class. That class might be a ready-made Java API exception class or it might be a user-defined exception class. For example, the exceptional conditions that I mentioned, division by zero, overflow, underflow, running out of memory, all these are something which are known beforehand. So for them there are standard exception classes available in the Java library. However, imagine a situation where a user tries to withdraw some amount from his bank account and he falls short of balance. There isn't enough balance against his account. He is trying to overdraw his account. That is to be rejected. So that's an exceptional condition that will occur only when you execute the program. Lot of information can be packed into the exception object in such a case. What is the account number, date of transaction, time of transaction, how much is the balance, how much did he attempt to withdraw. All this information can be packed into an object. But that object will have to be from a user-defined exception class. There cannot be a domain-specific exception class present in Java API. That's what I mean when I say that you will be possibly required to create an object out of a user-defined exception class. When you create this user-defined exception class, you are at liberty to inherit that class from any of the standard Java API exception classes. Advantage of this object-oriented exception handling is that more information can be packed into an exception object rather than merely the error number. I just now gave you a banking example as to what all information can you pack into the exception object. And secondly, and very, very importantly, you may have deeply nested calls and in the innermost call the exception occurs. Where to tackle it is your decision. You may tackle it in the first function, second function, third function, wherever you want. This exception object that is created in the last function, propagation of that to the place where it is being tackled is not your and my responsibility. That is the beauty of it. You just have to throw the exception object. Where to catch it, where to deal with it is something that you can decide. Propagating it from the place where it originated to the place where it is tackled, that's not your and my responsibility. That is something that the Java runtime will do for you. That's a great advantage. So much about Object-oriented exception handling. Actual program, of course, we are required to write, which we propose to do next time around. Till that time, goodbye, good luck, and thank you. Hi friends, I am Yashwant Kanetkar and I am here today to discuss one very interesting and important concept in Java programming, namely multi-threading. Now multi-threading is also somewhat related to multitasking and we should be able to understand the difference between the two very clearly. Multitasking means ability to execute more than one task at a time, where one task is nothing but a process. And against this, multi-threading is the ability to execute multiple parts of the same program at the same time or simultaneously. So this one part of the program which is executing along with other parts of the program, that each one of these parts is known as a thread, where a thread is nothing but a separate execution path within the program. Best way to understand this would be through a couple of examples. So let me show you those examples. Suppose you are using Microsoft Paint. At the same time, you can start PowerPoint, you can start Excel, you can run Explorer. All these are what? These are different processes that are running in memory. Each is a separate task. So that's multitasking at work. Or you may have Notepad with multiple instances of it. Right? You open one file in Notepad, then you run one more copy of Notepad, open another file within Notepad. So that is also nothing but multitasking. So the coexistence of different programs in memory or coexistence of the same program multiple times in memory, both of them would qualify as multitasking. That's why I have mentioned here that multiple instances of Paint program can run or multiple instances of Notepad can also run simultaneously in memory. When that happens, that's multitasking at work. Let's look at some examples of multi-threading as well. In Word, when you are typing, suppose you are deciding to type maybe a page full of maybe 7 or 8 paragraphs. Now it's not that you type out 8 paragraphs and then you figure out whether there is a spelling mistake or not. Spelling mistake is pointed out to you right where you actually type. For example, here I have committed a mistake in typing out the spelling of immortal. One M is missing here. But that's immediately marked out for me using a red colored underline. Or if grammar goes wrong, it's immediately pointed out to you through maybe a green colored underline. Point is that this happens on the fly. It's not that you type out everything and then you check the grammar, or you type out everything then check the spellings. As you are typing, the spellings are being checked. As you are typing, the grammar is being checked. When you run an antiviral program, it is going through a variety of files to figure out whether they have been infected by virus or not. I am sure you have done this scanning. But it's not that you complete the scanning once you initiate it. You can always pause it or you can always stop it. The stop button is always available for you for selection. So in the background, the checking may happen. In the foreground, the other user interface you can work with. You can pause it, you can stop it, you can schedule it. All those possibilities exist. And when that happens, what you are doing? Within the same program, you are running multiple units of execution or multiple threads, so to say. If I am to give you a couple of more examples, then when you are scrolling a web page, if there is any graphics or any music or any video within that page, you don't have to wait for that to get downloaded before you can scroll through the page. The downloading can happen in a separate thread, whereas scrolling can happen in a separate thread. So multiple units of execution means browsers that you make use of are basically multi-threaded programs. You can appreciate that. Or when you are printing out, let's say, one Word document, it's not that you give a 100-page document for printing and you have to wait till 100-page gets printed to work with the rest of the Word software. Yes or no? You can continue typing one document, another document you can send for printing. That's multiple units of execution at work. Means basically multi-threading at work. Lastly, when you are replying to an email, mails that are incoming in your inbox, they can continue to get downloaded. So downloading thread is different. Typing thread where you are sending a mail, that's a different thread. Point I am trying to make is that if you look around, most of the professional level programs which are popular, they are basically multi-threaded programs. So multi-threading is really very, very important. Its advantages being that it improves the application's responsiveness. I gave you the example that you don't have to wait for a 100-page document to get printed before you can start creating a new one. Both can happen simultaneously. So responsiveness of the application is bound to improve as a result. Secondly, it gives you a feeling that multiple activities are going on simultaneously. Printing is also happening, typing is also happening. But in reality, it is just dividing the time slot between the two. For some time this goes, for some time this goes, for some time this goes, for some time this goes. This keeps on shuttling from, or CPU's attention keeps on shuttling from one thread to another. This happens so fast that you get a feeling that simultaneously both things are happening. Not so. But that has also been overcome with the advent of quad-core or 8-core or 16-core processors, where you can actually do things in parallel. For example, if you are doing addition of two matrices, A00 and B00, its addition has got nothing to do with A01 and B01's addition. Both can be launched in separate processors. Yes or no? So multiprocessor can really encourage you to do parallel programming. So that's something which is very, very important. Within the same program, you can do multiple units simultaneously. And lastly, it simplifies program organization. Just imagine you have a file copy program, your file explorer. In one thread, copying happens. In another thread, the animation is being played. The green progress bar moves forward as the copying proceeds. So both are happening simultaneously. It simplifies program organization from the point of view of where you put the logic for copying and where you put the logic for progressing the green colored progress bar. If they get cluttered into one another, it's difficult to organize the program. Because here I am talking only about 2 threads. There might be 10 threads. If their logic starts getting mixed up, it becomes really a nightmare. So, multi-threading facility in Java lets you put these units at separate places and manage them. So, programs organization definitely becomes simpler if you happen to launch multiple threads within your program. So, several advantages. As we go along and write programs on multi-threading, I am sure you would be able to appreciate them better. Till that time, goodbye and good luck.